Write a query to display the last name, department number, and department name for all employees. This will be a simple query. We have to use referencing here. Let's start. Select, we need last name, department number, and department name. Department number is nothing but the column department ID, and then this is department underscore name. We'll be taking the information from two different tables. One is employees, the other one is departments. We need to alias the table names. So employees E, departments D, and also prefix the column names. E dot last name, E dot department ID, then D dot department name. In the last step, we need to reference the columns. So we can link these two tables using the department ID column. So in the where condition, you can add E dot department ID is equal to D dot department ID. Let's run this. You get the required data. Create a unique listing of all jobs that are in department 80. Include the location of the department in the output. Start with the select statement. We need job ID, and then we also need the location ID. From two different tables, one is employees, other one is departments. I'm aliasing it employees E, departments D. Job ID can be taken from employees table, so E dot job ID. Then location ID is in the departments table, so D dot location ID. Finally, where clause. We need to reference these two tables using department ID. E dot department ID is equal to D dot department ID. We need this information only for department 80. So, and E dot department ID is equal to 80. Let's run this. Yeah. It looks like there are duplicate values because we didn't add the keyword distinct. Let's run this now. Yeah. So you get the required output. Write a query to display the employee last name, department name, location ID, and city of all employees who earn a commission. Select these things. Last name, department name, then location ID, then city, from employees E, departments D, locations L. Last name from employees table, department name from departments table, location ID from departments table, city from locations table. Here we need to link three tables. E dot department ID is equal to D dot department ID. Then we need to link locations table with departments table. We can do that using location ID column. D dot location ID is equal to L dot location ID. We have linked the three tables. Finally, we have to filter it down to all the employees who earn a commission. Add one more condition, and E dot commission PCT is not null. This is the output. Display the employee last name and department name for all employees who have lowercase a in their last names. Last name and department name from employees A, departments D, last name from employees, department name from D, departments, where E dot department ID is equal to D dot department ID, referencing the two tables, and E dot last name like percentage A percentage. This expression checks for the lowercase a present at any position in the last name. You have last names and department names, and the last names have lowercase a. Write a query to display the last name, job, department number, and department name for all employees who work in Toronto. We can solve this using join. The syntax for join is select star from table 1, join table 2. We can use the keyword on if we have to use some conditions. So firstly, let's start with select statement. Select last name, job ID, department name from employees E, join departments D. Let me just prefix the column names. E dot last name, E dot job ID, E dot department ID, D dot department name. So select these things from employees E, join departments D. Now comes the on keyword. You have to write down the condition here based on which you will be joining these two tables. We will be joining these two tables based on department ID. So E dot department ID is equal to D dot department ID. So this will join these two tables. But then there is one more condition for all employees who work in Toronto. So we need the location information from locations table. So let's join one more table, locations, to this. Again use the join keyword. Join table name is locations, aliasing it as L. Join locations L on. Here you write the condition based on which you link the locations table and the departments table. That will be using the column location ID. So D dot location ID is equal to L dot location ID. Now we have joined all the three tables. Firstly, we joined employees table and departments table based on department ID. Then we joined locations table using location ID. Finally, we need to restrict the city to Toronto. So add one more condition where L dot city is equal to Toronto. There might be some inconsistencies with the spelling. So let's make this column lowercase using the keyword lower. Lower of L dot city is equal to Toronto. Let's run this. This is the output. Just a quick pointer on the join. An inner join or just join links two tables. It compares values in one or more columns from each table. It only returns rows which match the join condition in both the tables. Display the employee last name and employee number along with their manager's last name and manager's number. Label the columns employee, emp hash, manager and mgr hash respectively. There is no separate table for managers or there is no separate column in employees for manager names. You can only identify with the help of manager ID. That means to say manager is also an employee, so manager's information will be in one of the rows of the employees table. Manager ID will be one of the employee IDs. Once we find the match and identify the row, we can print any information that is required like employee name, that is the manager name, etc. The idea here is to join the same table. We'll be joining employees table with employees table. This will require two different aliasing for the same table. Let's see how. Let me directly go to the from part and then come back to select. From employees W, join employees M. So this is what I meant when I said we'll be aliasing the same table twice. On, the condition will be here, W dot manager ID is equal to M dot employee ID. First we fetch the last name of the employee and then employee ID, and then we fetch the last name of the manager and then employee ID of the manager or the manager ID. We have done a self join for the table employees. We take the employee information from the table W alias employees, and then we take the manager information from the table M alias employees. We have joined using manager ID and employee ID. I repeat once again that manager is also an employee. So if we get the manager ID and then match it with the employee ID, we can get the information of the manager. Let's run this. These are the employee last names, then respective employee IDs, then manager last name, then manager IDs. In the above, display all employees including King who has no manager. Let me take the previous query. Here, if I consider W as table 1 and M as table 2, this particular query fetches the intersection of these two tables, that is this part. This query will not fetch the employees who do not have a manager. So if we have to include them, we have to use the left outer join. In our case, T1 is W, T2 is M. We'll be fetching employees details from T1, so that is why we need a left outer join. Left outer join will include the intersection of the two tables and also everything that is left out in the table 1 or the left side table. There is also something called as right outer join, which is the opposite of this. Coming back to our query, we need to make this left outer join. So this will include the employees who do not have the manager also. You can see this last row, King is included, and that particular person does not have a manager, so manager last name is null and manager ID is also empty. This was an example for left outer join. Create a query that displays employee last names, department numbers, and all the employees who work in the same department as a given employee. Give each column an appropriate label. Let me just join the tables first. It is similar to the previous problem where we join employees with employees table itself. From employees E, join employees C on the condition E dot department ID is equal to C dot department ID. We have made the first table as E and then second table as C. E is for employees and C is for colleagues. So select department ID as department, last name as employee, C dot last name as colleague. So we'll be getting the second column as employee and the third column as a colleague. But this will give duplicate values. So we need a where condition saying E dot employee ID is not equal to C dot employee ID. This is because we don't want the same person's name in second column and then third column. We want the names of the colleagues. This condition restricts that. Finally, let's add order by E dot department ID, comma E dot last name and then also C dot last name. Let's run this. You can see this is ordered by department ID, also employee name and then colleague name. Show the structure of the job grades table. We have to use the keyword DESC for that. Okay, so this is the structure of job grades table. Create a query that displays the name, job, department name, salary and grade for all employees. Select E dot last name, E dot job ID, D dot department ID, E dot salary, J dot grade level. From employees E, departments D, then job grades J. If you don't want to use the join, you can link it or reference it using department ID column. And then E dot salary between the lowest salary and the highest salary. The other method is to use the join. We join employees E with departments D based on the condition of department ID and then join the third table job grades J based on the condition that E dot salary should be between J dot lowest salary and J dot highest salary. Let me run the first query. This is the output. The second method also gives the same output. Create a query to display the name and hire date of any employee hired after employee Davis. First we alias employees as E, then we alias employees as Davis because we need the hire date of Davis, that is Davis dot hire date should be less than employee dot hire date. That is the first logic. The second one is using join. We are doing a self join here. Select E dot last name and then E dot hire date. From employees E, join employees Davis. So here also the first alias is E, the second alias is Davis based on the condition that Davis dot last name is equal to Davis, identifying that particular row, and then add the where condition Davis dot hire date is less than E dot hire date. Both of these will give you the same output. So these are the people who are hired after Davis. same output. Display the names and hire dates for all employees who were hired before their managers along with their managers' names and hire dates. This also can be solved using join or without using join. Select these things, aliasing employees as W and then alias it as M, and then reference it with manager ID and employee ID. Then W dot hire date, that is employee's hire date, is less than the manager's hire date. So that will be restricted over here. If we have to use the join, it will be like this. Employee's first alias W, same. Employee's second alias is M, that is also same. Based on the condition, W dot manager ID is equal to M dot manager ID, where W dot hire date is less than M dot hire date. So these people were hired before their managers. Second method, the same output.